Hello everyone. In this session of Ccna series, I will discuss about first hop redundancy protocol, also known as Fhrp. So when a network designers design a network, they have to make sure the network is available all the time, that is 24 into 7. The reliability should be there and it should be fault tolerant. This is possible if you have redundancy in your network. So what is exactly redundancy? So let me explain the concept of redundancy with an analogy. Imagine you have a set of train tracks that connect one city to another. If something goes wrong with those tracks, like a tree might fall on the track or a track might break, and what happens is the train can't go through and the communication stops. So if you have multiple set of same train tracks that connect the same cities, and if something happened to one of those track, then there is another set of tracks available for the trains to use. This way, even if there is a problem on one pathway, there is a backup and the communication can keep going smoothly. Our network is kind of a pathway of information to travel from one point to another in a network. Now, let's say these train track represent your network connection and data packets are train traveling on those tracks. A redundant network is like having multiple set of train tracks that connect the same cities. And in redundant network, having those extra pathways means even if there is a problem, the packets can find another route to reach its destination. So this helps prevents disruptions, keeping things running smoothly, and ensuring that important messages get through even if there are like obstacles along the way. So redundancy in a network is very essential. So network uh, need redundant links to improve the availability of those network. So let's take a small topology where I have some hosts connected to LAN, and these LAN network, this is a company LAN network, small network, where I have a one WAN router, and these WAN router, and this WAN router is connected to internet via ISP1 router. Okay, so in this LAN, you can see there is no, in this network, there is no redundancy to the WAN router or ISP. Anything can fail in your network, right? A router power supply might fail, or a cable might break, or a switch might lose a power. And very important, even this WAN link might also fail. The failure of a single component might means an outage, and that will affect the end users. Network engineer refer to these components which bring down the part of the network as a single point of failure. Here you can see the LAN appears to have some redundancy whereas the WAN does not. And for that, the traffic flow between the host and the internet may disrupt. Any component which I mentioned fails will disrupt the traffic. To improve the availability, you can add another WAN router in the network so that one single point of failure now has redundant options, increasing availability. Now, if you see on the left side, we have two routers to support the LAN for the same. Let me add the IP addresses here. As I said, now on the left side for the same host, we have two routers to support the LAN, and for the same VLAN and subnet. Here we have a subnet of 192.168.1.0/24 with .10 and .11 assigned to the hosts, and the same subnet will have the link, IPs 1.2 and 1.3 on R1 and R2. But there is a problem with this design. as a host can be configured with only one default gateway. Either you can configure with R1 or R2. And if one of the gateways goes down, the user has to reconfigure the gateway. This is another drawback. So this is where the FHRP come into picture. FHRP makes this design work better. The two router appears to have a single default router. As a single default router, and the users never have to do anything on their default router setting. The default router setting remain the same on their side, and the ARP table even remains the same. So FHRP makes this following happen. Okay, so it will allow all host with it will allow the host to have only one default router, and the default router will share a virtual IP address from this subnet defined by the FHRP. As you can see, I have a VIP or virtual IP which is common to both the routers. So as I said, the default routers will share a virtual IP in the subnet defined by the FHRP. The virtual IP address will be used on host as their default router address. So they will have a gateway as this virtual IP as the gateway. The router will exchange FHRP protocol messages to decide which router will forward the packet. And in case of uh, failure, the responsibility will be shifted to the other router. For example, in the beginning, if we select R1 as the default router, so when R1 fails, it will shift the responsibility to R2 and it will become forwarder. There are three FHRP or first hop redundancy protocols available. First one is Hsrp, also known as hot standby routing protocol or router protocol. The second one is VRRP, virtual router redundancy protocol. And the third one is gateway load balancing protocol. But our Ccna curriculum uh, focuses only on Hsrp. So let's go ahead and discuss about Hsrp, also known as hot standby router protocol. Hsrp is a Cisco proprietary protocol. It operates as an active standby model. It allows multiple routers on a single LAN to share a virtual IP and a virtual MAC address which is configured as the default gateway on the host. As you can see here I have a gateway IP address 192.168.1.1, and if you see the virtual IP, it is same. So from the group of router, there is one router elected as the active router and another as the standby router. Here you can see I have R1 as active and R2 as standby. The active router assumes the role of forwarding the packets. And in case of failure, the standby router takes over as the new active router. And during the failure, none of these changes happen on the host. As I said earlier, the host gateway IP address will remain the same. The host keeps as I said, the same default address setting set in the virtual IP address. The active standby model of Hsrp means that this is another drawback, that in one subnet, all hosts send their packet through only one router. But Hsrp does support load balancing. Okay, so you can make both the router as a forwarder by load balancing between them. Okay, so Hsrp does support load balancing by preferring different routers to be the active routers in different subnets. So you can have different subnets in your network, and you can make both the routers work for different subnet as active router. Okay, so Hsrp can be configured to preferred one router as an active router in one VLAN. For example, for 192.168.1.0/network, R1 is active, R2 is standby, and the VIP IP is 192.168.1.1. And for the second subnet, for another host, I can configure it in another subnet with VLAN 20 with subnet 192.168.2.0. For this, then the active router will be R2 and the standby router will be R1. So in this way, you can load balance the Hsrp traffic as well. There is another way you can configure multiple instances of Hsrp in the same subnet called multiple Hsrp groups, preferring one router to be active in one group and another router to be active in another group. For example, I have put VLAN 10 in one group and VLAN uh, 20 in sorry. Here we can divide one VLAN into multiple groups. So host 1 will be in group 1 and host 2 will be in group 2. So group 1 will have a VIP IP of .100 and group 2 will have a VIP IP of 101. For group 1, active router will be R1 and for group 2, active router will be R2. So in this way, you can load balance even if you have the same subnet as well. That's it for this session. I hope this was informative for you. Thank you. If you have any queries, then definitely you can contact me through any email. Through email, or you can send me a message. I'll be glad to help you guys.